So today we're gonna be integrating another beautiful integral from the MIT integration, but this time from the 2012 competition. And once again, we're gonna be solving something with my favorite function involved, which is the floor function. Just absolutely love inside of integrals. Like really. And this time there are two of them actually, because we are integrating between 1 over 4 and a half the floor of the natural log of the floor of 1 over x with respect to the x. Oh man. So how are we supposed to solve this problem? Let's first of all try and just kind of look at this argument here, namely the floor of 1 over x. How does this thing behave on this interval between a quarter and a half? Let's just draw it out. So I would like to draw the graph of 1 over x. It looks something like this, let's say. That's my y-axis, that's my x-axis. And now at x equal to 1, the value of my function is 1. At x equal to a half, the value of my function is a 2. At x equal to a third, it's 3. And at 4 is going to be, at quarter is going to be a 4. Lovely. So this is 1 over x, but what about the floor of 1 over x? How would that function look like? So you know that the floor is just kind of a function that will bring you down to the closest lower integer when given some kind of a real value. And so on this interval between a half and 1, where all of the function values are actually between 1 and 2, this function floor is just gonna bring us to y equal to 1. On the second interval between 1 over 3 and 1 over 2, the values of 1 over x are between a 3 and a 2. So the floor is going to bring all of those to a 2. And so we're going to get another piece of the function like this. Then on the interval between a quarter and a third, we're going to have the function values between a 4 and a 3. So all this is going to be brought down to a 3. And we're just going to continue just building those infinite steps on and on and on forever, just like this. And this is the graph of the floor of 1 over x. But I'm just kind of thinking, we only really care about the interval between 1 over 4 and 1 half. So, well, this interval that I absolutely awfully denoted, marked with those green lines. So this interval right over here, yeah? And so the only values that we actually care about those values right here. Maybe I will just kind of encircle them. Yeah, so those values there. But it just means that we could actually pretty much just go on and make our integral become 2 integrals, just kind of on sub intervals of the interval that we're integrating the original one on. Let's go on and do it, because now if I were to disconnect this integral and make it become 2 integrals, the integral, first of all, between a quarter and a third of the floor of the natural log of the, and now floor of the 1 over x on this interval between 1/4 and 1/3 becomes 3. And so we get that it's going to be just the natural log of a 3. That's going to be all with respect to x. But now, well, it's just a constant. That's a nice thing. And then on the second interval between a third and a half, so the integral between a third and a half, well, on this interval our floor of 1 over x is going to give us 2. So we're just gonna have the floor of the natural log, of 2 dx, and this is perfectly the same as the original integral we were trying to evaluate. So now let's just focus on evaluating those two guys. Well, how can we do this? Well, first of all, we should kind of note that the natural log is just the same as the logarithm with the base of e, where e is the Euler's number, like 2.71828, stuff like this, yeah? And so if we're taking the logarithm base e, which is less than 3, of 3, well, this thing is surely going to be equal, is going to be greater than 1, but it's probably not going to be greater than 2. It's going to be somewhere around, you know, maybe 1.2. I honestly have no idea, but doesn't really matter because the floor of that thing is going to be definitely equal to just a 1, so I don't really care about the exact value. And so we can just say that this thing here is just going to evaluate to a 1. But now, what about the logarithm base e of just a 2? Well, 2 is less than e, but it's not going, but this exponent here is not gonna be a negative value. So we're gonna get something between 0 and 1, but this means that the floor of this thing is just going to be 0, and so this floor right there is just going to be a 0. And so we don't really have to evaluate this integral at all, because a definite integral of a 0 is just a 0. Not a problem, yeah? And so we can, well, first of all, make up some space here, because I definitely did take too much of it, and just evaluate this guy out, and that's gonna give us just about, well, x between the bounds of 1/4 and 1/3, giving 1/3 minus a quarter, which is 1/12. Hope you guys enjoyed it, and see you in the next one.